Hello everyone, welcome to this second video in a series of videos about forecasting in supply chain management. Let's talk about, so in the previous video I introduced you to the idea of what is forecasting, why do we do forecasting, and in this video we'll talk specifically about time series based forecasting. So time series data is data that is collected at equal intervals of time, representing either demand or sales or some component of demand of some product or a group of products for that matter, right? So the way you do this, you collect the data at equal intervals of time. Another example of time series data is, say, a temperature data or stock market data. When you collect, let's say, the ending price, the price at which Google stock ended at the end of a business day for the last 100 days, that's time series data. The same goes for if you look at Philadelphia and you look at what was the temperature at 5 a.m. in Philadelphia for the last 100 days. Well, that's time series data collected at equal intervals of time, right? So when you have a time series data, even for products that have pretty mature demand, you can never expect demand to be completely static. There's always going to be a random component to it. So whenever you observe any sort of demand, there is a systematic component to it and there is a random component to it. And the best we can do is capture the systematic component. Capturing the random component obviously is, well, impossible because it is random, right? And this systematic component can potentially include three different different parts, right? So you have something called the level, trend, and seasonality, right? So level is demand that is that's a steady demand that you have, right? Now this is the steady demand that would exist if there was no trend in the data or no seasonality. Now before we define level, let's talk about trend and seasonality. So trend is a continuous growth, a continuous decline in demand. Now this happens right at the beginning or towards the end of a life cycle of a product. Now towards the middle of a life cycle of a product, the demand tends to be pretty stable, and trend is something that you don't see that much. But when the product is really hot or the product is not selling at all because it's towards the end of the life cycle, you see a trend. So you see an increasing trend in the beginning and you see a decreasing trend in the end. Now seasonality, as the name suggests, obviously is a predictable seasonal fluctuation in the data, right? So umbrella sales. So when it's really hot out or when it's raining, there will be a lot of sales of umbrellas. But in the winter, not so much, right? A good example. Raincoats are another example. Sweaters are another example. Flowers are another example. So you have specific holidays around which you have seasonality. Now, seasonal demand and seasonal inventory management is something that we will talk about in detail towards the end of the semester. But here we are just looking at how do you capture that seasonal part of the systematic component of demand. That's what we'll be talking about, right? So trend is a steady increase or decrease. Seasonal is predictable seasonal fluctuation, and level is the remaining demand. So when you have a certain amount of steady demand that you have, that is the level, right? And then on top of that, you might have a trend because the product is really hot, or the product is not selling well, or you might have seasonality because there are seasonal variations, right? So we will see how you can capture all three aspects of the systematic component. We will never be able to capture the random component, but how do we measure how much we were not able to capture, either because we did not get the full systematic component or, well, because there is a random component, is we will measure forecast error, right? Now this is the difference between the forecast and the actual demand. That's the difference. Now, in real life, capturing demand is not that easy, right? Say, for example, if you have 100 units of inventory and 90 people came to your store to buy whatever knick-knack you're selling, then you know what your demand was. It was 90. Let's say you have 100 units of inventory and all 100 units sold out. What is your demand, right? Was your demand 100 or was your demand 110? Maybe there were 10 more people who wanted to buy a product, but they could not because you did not have a product. Now, in some cases, it's like if somebody literally goes to a store owner and say, hey, I wanted to buy cereal, but you don't have cereal on your shelf. They might say, yeah, it will come back in a couple of days. And if that's the case, then you can count that one person as lost sales, and that will be part of your demand. But it's not always easy to capture demand on top of how much inventory you actually have, right? So demand is not easy to capture, but assuming that we are able to capture it, we can do a lot with it. And that's what we'll talk about today, right? Okay. Now, right. So the 5 important points in the forecasting process. So one is you have to understand the objective for forecasting. What is it that you're forecasting and why you're forecasting that? And then you have to integrate demand planning and forecasting throughout your supply chain. And this is something that companies have been doing more and more often now, because it is much easier to capture data and much easier to analyze data these days than before. Right. It's also important to identify the major factors that influence demand. We will, with time series analysis, understand what the end product, but what are the factors that affect the end product? That's not something you can capture with time series data, right? What you can do with forecast is you can look at forecast. One of the things is you forecast at the appropriate level of aggregation. Now, what does this mean? It's important to understand this portion. This portion, what you're talking about is, let's say that Apple wants to forecast how many iPhones they'll sell next month, for next year, for example. Now, are they going to forecast the number of units of iPhone 17 Pro Max with 1 terabyte hard drive, or are they going to forecast demand for all of iPhone? Now, it can clearly be shown that the more you aggregate data together, the smaller the random component is going to be. So because that's the case, if Apple forecasts demand for all iPhone first, and then disaggregates that final number into smaller pieces, that is more accurate than just forecasting for each individual iPhone line, right? So the more aggregated your data is, the lower your errors are going to be. And that's something that we'll talk about more when we talk about the aggregate planning process, right? And finally, we have to establish some performance and error measures and see how well your forecast is doing, right? So let's actually get to time series forecasting, right? So now there are different methods of time series forecasting. You have multiplicative decomposition, you have additive decomposition, and you have a mixed decomposition. What I will go over in this class is we'll go over multiplicative decomposition, because I feel that when we use multiplicative decomposition, it yields better results. Now, additive and mixed decompositions are also the methods also exist. They are pretty similar. So what I will do is we'll go over multiplicative decomposition. You can read about additive and mixed on your own, but it's not going to be part of the syllabus for this class. Now, there is a lot of formulas and whatnot, but instead of showing you the formulas, what I'll do is I'll move over to an Excel file where we'll actually go through this process. I'll show you how to do the process step by step so you understand the different stages in the process, because some of these formulas you'll notice here, they are pretty complicated, right? And there's no reason to look at these complicated formulas when it's much easier to see the method itself and then learn from the method, right? So I'm going to use the same data, the Tahoe Solve data that's there here, and then we'll do this forecasting, right? So I'll see you all in the Excel sheet in a second. Well, I noticed that this video is getting close to 10 minutes anyway. So what I'll do is I'll cut this video here. In the next video, we will go over the multiplicative decomposition methodology, and then in subsequent videos we'll talk about other methods and also forecasting error. All right. Okay. I'll see you all in the next video. Take care.